Hey guys, and welcome back to yet another grade 9 style question. So just as a reminder, in the description there is a bunch of other grade 9 papers that I have done full walkthroughs for, as well as links to their papers and the mark schemes and all that fun stuff. But we're going to go through the 2024 paper 2, so it's the calculator version. This paper is honestly not as bad as some of the ones that I've done in previous years, so I would recommend going to the previous sets as well, so set 1, 2 and 3 and doing those. The first set are probably the most tricky. However, the questions are very different. So they're quite tricky in the sense that they're different styles of question that they can ask you. And as you've seen from paper 1 already, the style of question has changed up a bit this year. So without further ado, let's just jump straight into it. I'm going to walk through all the questions, explain my thought process and exactly how I'd approach these questions. And of course, this will give you a full essential mark scheme to how you would complete them. So the first question here, we have some stratified sampling, a very common calculator paper, but we have 258 Year 9 students were choosing subjects they'll be taking in Year 10, and we have geography, history and Spanish, and male and female. And they're going to do a sample of 50. So work out the number of male students studying Spanish in the sample. So all you need to do for a stratified sample is to work out, or not even work out really, just count how many male students studying Spanish are there. Well, if we look at male and we go to Spanish, there are 26 of them. Out of a total of how many? Well, there are 258 students in total. Now, this proportion, which is the proportion of all Year 9 students that are male and studying Spanish, should be the same as the proportion of those in this group of 50 students that we're taking a sample of. So this is our fraction, and we're just going to times it by the sample size. And this gives us roughly how many students we would need in our sample. Now, I'm willing to bet this isn't going to be a whole number, so I'm going to show you what to do if it's not a whole number. Okay, multiplied by 50, we get, so 5.03. Of course, you can't have 0.03 of a student, so we're just going to round it to the nearest number. We're going to say 5 students. So we're going to take 5 males who are studying Spanish to put them in this sample size of 50. And that's again because the proportion of men studying Spanish is 26 out of 258. That proportion should be the same in our sample. So the number of female students, again, we're going to look at the female. We actually have 25 plus 48 plus 62 females. Don't forget all of the females. So we're going to do 25 plus 48 plus 62 all over, again, the total number of students in Year 9, 258. And once again, just times it by 50. Nice and easy. However, it is something that a lot of students get wrong because they kind of forget to study it. And I can see why it's not exactly something you would necessarily remember. It doesn't come up too frequently. And again, decimal 26.16. Let's just call it 26 students. So we're going to take 26 females and therefore 24 males in this sample. In this paper, there are actually a couple of proofs, as you can see here. And proofs are, again, something that some students struggle with. It is very common to have them in the calculator paper because you simply don't need a calculator for them. So to prove that this is a multiple of 4 for all positive integer values. Now, whenever you're proving that something's a multiple, all it means is you should be able to factorize a 4 all the way at the end. So if you're proving something's a multiple of 3, you'd factorize out 3. Proving it's a multiple of 6, factorize out 6. If you're proving something's even, it means it's a multiple of 2, so you factorize out 2. So how do you do this? You're going to need to expand and simplify. Now, I would recommend, because there is a negative here, leaving it in brackets for now. I mean, you could probably do the first one without that. So 3x times 3x is going to be 9x squared. Then you're going to have plus 3x plus 3x, so that's plus 6x. And then we're going to have plus 1 at the end. Then minus, and we're going to have something fairly similar. We're going to have 3x times 3x, which is 9x squared. Then we're going to have minus 3x, that's minus 6x. And then we're going to have plus 1. Now we can do the taking away. Well, we have 9x squared, take away 9x squared. If you want, and you don't believe me, you can just expand the brackets and you can literally see that it works, right? You have 9x squared and then minus 9x squared. 6x minus minus 6x would actually be 12x. And lastly, we have 1 minus 1, which is shockingly 0. Just like that. So we have 12x. Now, can I factorize out a 4 from 12x? Well, the answer is yeah. I could do 4 times 3x. So therefore, it is a multiple of 4. I'm going to just quickly explain. Again, if you want to, you can just skip ahead, but I'm going to explain why this works just for those of you that are interested. If you think about it, whenever you have a factor of a number, then that number must be a multiple of it. So for example, if I think of the number 16, one of its factors is 4 times 4. So in other words, it must be a multiple of 4 because it's in the 4 times table. We're saying that 12x must be in the 4 times table if we were to solve it. That's all that means. We have a classic style of geometry question where we have two shapes interlinked with each other and we need to find the area of the shaded region. Now, how do I approach this? Quite simple. I start with writing an equation. Now, it's not an equation I'm going to substitute numbers into. That might sound a bit weird. But overall, what's the step? Well, if I want the shaded region, I don't know what shape this shaded part is, right? It's like this weird curved thing. But if I take the area of the entire triangle and I take away this small kind of part here, this arc part here, I will be left with the grey area. So it's the area of the triangle minus the area of that pizza slice, which is a sector. That's what I'm doing overall. The reason why I really want to make that clear is because a lot of students do overcomplicate things. And they look at that and they go, oh my god, crazy. If you write a formula, well, now all you're asking yourself, you can actually forget about this. You can just ask yourself, do I know what the area of a triangle is? Yes. Do I know what the area of a sector is? Yes. And you're done. Now, with the area of a triangle, you might be tempted to say base times height. If you want to do that, you'd need to work out the height of this triangle, which means you have to use some Pythagoras. I've got another way. The general area for a triangle is half AB sine C, which you do get given in your formula booklet, so that's nice. Now, if you think about it, this is an equilateral triangle because it tells me. That means the angles are all 60 degrees. So my formula for the area of the triangle is going to be a half times 6 times 6 times sine 60, which is way easier than using, or rather simpler, than just using the Pythagorean theorem to work it out. So half 6 times 6 sine 60. And what about the area of a sector? Well, what is a sector? Well, I call it a pizza slice because it illustrates the point really clearly. It's just a section of an overall circle. So the actual circle goes on all the way around like this. So if we work out what fraction of the circle this pizza slice is, we will then know how to work out the area. How do you work out the area of a circle? It's pi r squared. Now, here's the question. What determines what fraction of the circle this pizza slice is? Well, it's all to do with the angle. It's how much of the angle we've taken up. What do the angles in a circle add up to? 360. What angle do we have? We have 60. So it's simply 60 over 360 times pi r squared, where r is going to be... Well, it says that point Q is the midpoint of AC. So it's not going to be 6 centimeters. It's going to be 3 centimeters because Q and P are the midpoints of the lines. So the radius is just going to be half of the line AB or AC. So we have 60 over 360 times pi times 3 squared. You could simplify this if you want, but it's a calculator paper, right? Who cares? We don't need to do that. You do get marks for having these kinds of equations put into place, which again is why I like saying this. That gets you a mark. So even if you have no idea what a triangle is, or at least how to work it out, you can still write these equations to get some marks. So let's have a look-see. We have a half 6 sine 60, and I might just press equals and then do subtract, just because I like to keep everything a bit neater in my calculator. It makes me able to spot mistakes more easily. Now, if I've made a mistake, that's going to be really embarrassing because I've said it's easier to spot them. And we get 10.876 blah blah blah, 3SF, so 10.9, and this would be centimeters squared. Although they give you that, so we don't need to worry too much. For 4 marks, I don't think it's too bad. However, I can foresee some challenges with this question. Making A the subject of the formula. This is something I've noticed that, especially with the current cohort, they find a bit tricky. But essentially what you're trying to do is get A by itself. If you have a square root, you have to get rid of that first. So we're going to square both sides, which means that would be x squared. that'd be a over 3, because when you square a square root, the square root goes away, times both sides by 3. Yeah, not too bad. Again, if you do want to see harder questions, I would really recommend going to the description and looking at the previous sets, because they genuinely are a lot trickier. This paper wasn't too bad, but there are a few tricky bits, but again, I'd recommend doing that. Really classic standard form question, comes up in calculator quite a bit, so let me just go through this. Writing 12,500 in standard form, here's my trick. I write the first non-zero digit, so 1, and I put a decimal point afterwards. Then I write all of the other non-zero digits, so 25. Then I put the times 10, and all I do is I count how many digits are after that first digit I wrote, so after the 1. There's 1, 2, 3, 4. 1, 2, 3, 4, yeah. And that would be it. That's all I'll do for working out that one. Writing this as an ordinary number, there's a few different ways you can do that, but essentially this 10 to the minus 3 means there should be 3 zeros before the 2. So I'm going to put 3 zeros, 2, 4, 8. And then all you're going to do is, of course, you need to have a decimal point somewhere. I put the decimal point after the first 0. That's all I do. With this we can use a calculator, but judging by the wording of the question, it means my answer will not be in standard form. So let's just do this. I would do it as a fraction just because I prefer it personally. 5 times 10 to the power of minus 4. Yeah, okay, figures. So again, same technique. I'm going to write the number 1 because it's my first non-zero digit. Then, a full stop, a decimal, and the other non-zero digits. So that's 1.88, and then I just count how many digits are after the 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. God, my eyes. All right, times 10 to the power of 8. Not bad, not too bad. I actually really like this topic because once you really understand it, once you've broken it down really nicely, it is quite an easy topic. Again, if you find it confusing, I do think it's the way it's taught is not the best in the world, in my opinion. But we have two shapes, x and y. They have this surface area, and they give you the mass of x. Now, this is a really common thing that they do in the exam, is normally the scale factors we're talking about, just in case you weren't sure, whenever they say mathematically similar, you should be thinking scale factors, is the length scale factor, LSF, the area scale factor, and the volume scale factor. So then when you hear about this mass thing, it confuses people. But all you need to think about is because these materials are made, these shapes are made from the same material, it means that we are looking at the volume scale factor. If you want to know the physical reason why, it's because that means their densities are the same, which means their masses are only dependent on the volume of the object. If you think about it, like if I give you a small metal ball versus a big metal ball, that's just the volume that's changed, which changes its mass. Anyways, enough of the physics lesson. First thing we want to do is we want to work out the scale factor. So I like to write out length scale factor equals area scale factor equals and volume scale factor equals. I like writing that out just because then I can slot in what I need to know. Then I ask myself, what have they given me? Well, they've given me area and they've given me volume, right? So, because I only know the areas of both, that must be the scale factor I'm looking for. So I'm going to do 50 over 18, which is 25 over 9. I'm actually going to leave it in that. And I want to get the volume scale factor. Now, you can't go from area to volume, so what you need to do is go down to length first. How do you go from area to length? Use square root. 25 over 9, which is 5 over 3. And then to go up to volume, you just cube it. So 5 over 3 cubed, which is 125 over 27. Cool. Now, we know that the mass of this one is 500 grams, and we're trying to get the mass of this one. Some students are unsure of when you times, when you divide, so I prefer to just eliminate that entirely, and I prefer to just say, okay, if I look at those two shapes, should my number get smaller or bigger? That's the way I think of it, because it's easier than remembering, oh, this is the x to y scale factor or the y to x scale. Screw that. Think of it like this. This object is bigger, so it should weigh more. It should have a bigger mass. So if I'm going to a smaller object, I need to make my number smaller. Cool. Generally speaking, dividing makes things smaller, but you can even ask yourself, if I divide by 125 over 7, will it make it smaller? Well, you can literally check, right? It's a calculator exam, so there's no harm in you just going, okay, so 500 divided by 125 over 7, will my number get, 27, will my number get smaller? Yeah, it gets smaller. Just in case you're unsure and you did times first for whatever reason, you can say, oh, it's bigger, then it can't be that, I can go and change it. And then you can write your working out. Right, what's stopping you from doing that? How will the examiner ever know? They won't. So that's what I would do. Again, this is about survival of the fittest right now, okay? We're trying to survive. For 4 marks, this is such a good question. Really, I love scale factors because the maths is quite short, the numbers are quite easy, and you get a ton of marks for it. So really, really useful. Fairly similar to the last question. So we have a sector of a circle with centre O, gives us the radius, it gives us an... Honestly, the whole arc and the chord thing, not too meaningful to be honest, because it tells you it's a sector anyway, so of course this is an arc, and this is obviously a chord, so it's not useless information, but it's information that's kind of already displayed for you. They've given you this 40 degrees, and it says calculate the area of the shaded segment. Once again, I'm going to use the trick. We can't really work out the area of this directly, although there is technically a formula, but it's not one you have to know. All we need to do is work out the area of this pizza slice, and then subtract the area of this triangle on the inside. And once again, you could do base times height if you want to. The only thing is you'd have to work out the base and the height, so I would probably recommend just doing half AB sine C once again. So again, the area of a sector, as we've already done before, it'd be 40 over 360 multiplied by pi r squared, so pi times 8 squared, subtract half AB sine C, half A is 8, B is also 8, and then sine of 40. And that's it, 3SF again, another 5 marks? Really? Interesting. Okay, see, math is easy, right? Just kidding. So, let's do it like this. Let's do 40 over 360, not 260, multiplied by pi, multiplied by 8 squared, all this equals, then I'm going to subtract half 8 times sine of 40. 1.77 centimeters squared. And yeah, that's it. Again, if you do want to find harder questions, I'd recommend the previous ones because they are a lot harder than this, but there are also 27 questions in this paper, so it does get a bit trickier. This is the first kind of interesting question that we found because it's very different to the other styles of question that you may have come across. But again, that's what you need to expect whenever you do papers, because the misleading thing about past papers is that it seems like the questions kind of stay the same, but they don't. There was the first year where each question came up. Then they may change the numbers for following years and change the situation, but something like this coming up this year is perfectly reasonable. So this is a type of algebraic proof. So you have 6 expressions, 2x minus 3, blah, all of that. And then we need to find the expression whose value is always even and always a multiple of 3. So always a multiple of 3 would definitely be 3 open bracket x plus 4. Because, as I mentioned before, if you want to prove something's a multiple, all you want to do is factorize out of 3. So now let's see the always even one. Well, none of these have a 2 factorized out, and in fact none of them could be factorized by 2. But if we have a look at this one here, what I'm going to do is I'm going to expand it, 12x plus 4, then I can factorize out a 2. Whoa, careful there. I can factorize out a 2, so this one here is actually always even. So now you're probably thinking, okay, well how did I know that I could do that? And I haven't done the question before, just so you know. First things first, well, I can look at these really quickly and say that can't be even because I can't factorize out from the 3 a 2. This one, again, can't factorize out 3. This one's factorized out 3, so it definitely doesn't work. This one's a plus 1 again. So all the ones with plus 1 or like a negative, an odd number, I can just get rid of straight away. But the other thing is that if something is a multiple of 4, it must be a multiple of 2. In the same way that every multiple of 6 is a multiple of 2, every multiple of 8 is a multiple of 2, every multiple of 10 is a multiple of 2. Because they're all even. And so that's another way that you can figure it out. Lastly, from the table, write the expression which is a factor of 4x squared minus 1. Again, what I would do here is I would try and factorize this. How do I know I can factorize it? Because it says, write the expression that's a factor of. Now, this is actually the difference of 2 squares. So you may have seen this be written as something like x squared minus 25 before, and then you'd write x plus 5, x minus 5. Now, the thing that kind of annoys me about the way it's taught sometimes is they don't tell you that it's also the front thing that is a square number. X squared is a square number. 4x squared, can I square root it? Yeah, if I square root 4x squared, I get 2x squared. So that's also a square number. Is 1 a square number? Yes. So 4x squared minus 1 factorizes to 2x minus 1, 2x plus 1. Because again, this difference of two squares here, well, if you think about the name, difference of two squares, it applies to the first thing and the second. We square root both of them. See, square root of x squared is x. So, if we look for the one that's 2x plus 1, it's 2x plus 1. So 2x plus 1 is the factor of 4x squared minus 1. Inequalities, cool. Show the inequality on a number line. Again, this is something that is normally only on foundation, and it's kind of funny because it does trip up higher students sometimes. So here's how I would do it. I would put a circle at the number. So here, minus 3. The next question you ask yourself is, should it be coloured in or should it be hollow? Well, if there is no underline, then it's hollow. So you only colour it in if it is equals to. If it's not equals to, then we do not colour it in. Then you need to decide which way the arrow is going to point. Well, this is greater than minus 3, so it should be pointing to the right. Greater than is always to the right, less than is always to the left. That's it for 2 marks. What are your marks for? 1, you've got the right number and arrow direction. The second mark is for having it hollow instead of coloured in. Solving inequalities. A lot of students do have trouble with this, so here's what I'd recommend. I would treat it exactly like an equal sign. So if you know how to solve this, then you know how to solve this in the exact same way. So subtract 36 from both sides, that's what I want to do. So we get 7x less than equals to 8 minus 36 will be minus 28. Then divide both sides by 7, you get x less than equal to minus 4. Again, that's the same steps you would take for this equation. It's the same thing. Do not worry about it. Here's a reverse percentages question. In a cell, the normal price of a pen is reduced by 10%. The sale price is now £4.86. Calculate the normal price of the pen. So all I would do, and this is my way of doing it, is if it's been reduced by 10%, then that means it's currently at 100, take away 10, it's at 90% of its original value. Which means 90% of the value of the pen is £4.86. So you could do either 0.9x equals £4.86, you could do 90% equal x equals £4.86, or you could even do just say 90% equals £4.86 and then go up. So for example, if you said that 90% equals this, you could divide down to 10% and then go up to 100%, whatever you want to do. I prefer this method because all I have to do is one thing, which is divide both sides by 0.9 or by 90%, it's the same thing, and I'll get my answer. Nice and quick, and I think this was for 3 marks if I'm not mistaken. Nice and easy. So £5.40. Cool. And yeah, 3 marks, perfect. We have another similar shaped question. So we have 2 similar triangles here, ABC and XYZ, Z even, not Z. And we have to work out the length of BC. So the way we do this is you want to work out the scale factor. So depends how you want to look at it. Do you want to go from the smaller to the larger? I personally like to go from small to large. So to go from this, so length scale factor, to go from the smaller to the larger shape, all I want to do is do 10 divided by 6. You always want to pick sides that are corresponding to each other. So what that means is XY is of course the same length AB, AC is the same as XZ, and BC is YZ. And that is the scale factor. We want to find out BC, that corresponds to YZ. So BC is just equal to YZ, which is 12, multiplied by 5/3, which would be 20 centimeters for 2 marks. Calculate the length XZ. Well, in this case, we're going from the bigger shape to the smaller shape, so use the trick I said before. If I times by 5/3, the number will get bigger. That doesn't make sense because the shape's smaller, so I'm going to divide by 5/3. So 18 divided by 5/3. Can I do that in my head? Maybe, but I don't need to. So 18 divided by 5 over 3 gives me 10.8 centimeters. And that is all we need to do for that question. Here we have another, I'm just going to call it a standard form question. It gives us the surface area of Venus and Jupiter. And it says the surface area of Jupiter is greater than Venus. How many times greater? So you're going to take the surface area of Jupiter divided by the surface area of Venus. And then we're just going to give our answer in standard form, apparently. So we're probably going to get quite a big number. 0.72000. Excuse the messy handwriting. Go through this. 6.21795. Yep. Times 10 to the power of 10 over 5100.72000. And we get, okay, you want me to, really? Okay. I'm going to call it 122 then. Yeah, sure, 122, and then we'll change that into standard form, which is 1.22 times 10 to the power of 2. Yeah. Cool. Yeah, again, we have a very different style of question. The table shows some expressions. X, Y, Z, and W represent lengths, pi into a numbers. 2's a number, okay, that have no dimensions. Which expressions could represent volumes? Very interesting indeed. I would actually imagine this in like A-level physics, believe it or not, because it's talking about dimensions. It's talking about the units for volume. If you think about volume, it should have units of centimeters or meters cubed. So what we're going to do is if we say all of these, X, Y, and Z and W all have units of centimeters, we can work out what the units are for all of them. So for example, if I have y squared, x plus z, well, y squared is of course going to be centimeters squared. X plus z, well, if you think about it, if I'm adding two lengths together, it's just going to be centimeters, isn't it? Like if I add 5 centimeters and 10 centimeters, I get 15 centimeters. The units don't change. If we multiply them, we get centimeters cubed, which means it is indeed a volume. So that's one of them. Now pi, w squared, y squared, well again, that would be centimeters squared times centimeters squared. Pi has no units, so we don't need to write it. That would be centimeters to the power of 4, which is not volume. So it's not going to be this one. And we can keep going forward. You might be able to start doing this in your head, but again, just in case for those that can't, this would be centimeters cubed times centimeters, that's centimeters to the power of 4, divided by, so centimeters to the power of 4 over centimeters cubed would give me just centimeters, so it's not that one either. W squared, x squared, well that's going to be centimeters squared times centimeters, which is centimeters cubed. That's a volume, so that's good. And I can see this one's probably going to be it. But anyways, w cubed, so centimeters cubed times centimeters is centimeters to the 4, divided by centimeters would give me centimeters cubed again. And because we know that there's only 3, I don't even need to worry about the others. And that's 3 marks. Pretty good. Again, it's a different style of question, which is where it might throw some students off. With dimensions, it's very rare that I see teachers, granted I don't see that many teachers, but it's rare that I see teachers talking about the dimensions of volume and things like that, like what could represent a volume, an area, or a length. But there's no reason why they can ask you it. Okay, dimensions and units of length, volume, and area are all on your spec, so just be careful with that. So we can basically do this stratified sample in the same way as before. So we take the number of people from Longridge, divide it by the total number of people, which is, I'm not even going to bother working out, I'm just going to write it all on here. Add 900, and then we just times it by 50. Because what we want to do, this part of the equation works out what fraction of the people work at the Longridge site. And then that fraction of people should be what fraction of the sample are going to be from the Longridge site. So just doing it all in one step because we're nice and lazy. So 700 over 750 plus 700 plus 900. Then multiplied by 50 gives me, great of course, 14.89, so I'm going to say 15 people. You can make an argument for rounding down, it's totally fine, but the idea is that you need to give a whole number for the number of people, shockingly. So we have some more inequalities. So first of all, on the number line, show the inequality -2 to 3. So again, put those circles on the numbers that they say. And again, ask yourself, do they need to be coloured in? Well, it's not equal to, so we don't need to, and we're just going to draw a bar. This is the only case where you wouldn't have an arrow, is if they give you I call it a double-ended inequality, but essentially we have multiple inequality signs. Here's an inequality y shown on a number line. Write down the inequality, so y is going to go in the middle. Then I'm going to write the numbers, so -3 and 4. And then you have to ask yourself if they're going to be, well, I mean, they're both going to be less than, but are any of them or either of them going to be underlined? Well, the one that's coloured in is definitely going to be underlined. The hollow one is not going to be. And again, solving the inequality, add 5 to both sides. 40 is greater than 14. And then we have t is greater than 7/2, or 3.5, however you want to look at it. Nice and easy. This question, it's pretty much going to be the exact same thing as what we did before. So it's going to be the area of the sector, subtract the area of a triangle. So that's going to be 35/360 times pi 80 squared, subtract, and then we're going to have half AB sine C. So 80 sine 35. This actually brings you to a good point. I actually have I found an Edexcel produced booklet of grade 9 questions. I haven't looked through the whole thing. I've scrolled through, there's quite a bit there. I'll leave it in the description, but if there are any you want me to go through, that would be also another potential revision strategy where I just pick the hardest possible questions and then go through them. But if you have any topics that you want as well, leave that in the comments, and then I can see basically which ones have the highest demand, and then we can just go through them, and it should be quite fun. I have covered the majority of topics on the channel before, if you are interested, but it might be interesting to go through some more of the questions that have come out more recently. So yeah, just let me know what you think of that. But other than that, I'm just going to type in this equation. I'm not even going to do the thing I did before, which was, whoops, that's a 9. There we are. Whoops, hello. 735. Well, obviously that's not correct. Why has that not happened? It's probably the way I've typed it in. So let's do this instead. I still did the 90. I typed the same thing in again. Take away half 80 times 80 sine 35. There you go, 119.3. Or just 119, because it is it's told us that. Is it centimetres? No, it's meters, of course it is. Meters squared. All done. So another way of taking stratified samples is when you have the group like this, but they give you the totals. So again, the number of year 13 girls, so we go to year 13 and girls, that's 85. Out of a total of 382, and you just multiply that by 50, the sample size. Nice and easy. Not gonna lie, again, like I said, this isn't the best one that Edexcel have put out, to be honest. Not gonna lie to you. The other ones are better if you want trickier questions. So again, I'll leave all of them in the description, but they are very good questions in there. But that's just going to be 11. One's a little bit repetitive and not too bad. But hopefully you're still finding it useful. Proportion is actually one of my favourite topics as well, along with kind of compound interest and things like that, because if you find a formula, it's 3 marks. You get marks for the same 3 steps every single time. The first is for using this. If it's directly proportional, you just write y equals kx. 1 mark. Easy. The second mark is for subbing in and finding what k is. Again, nice and easy. 500x. No, not 500x, 500k is what I meant to write. And that means k is equal to 10 over 500 or 1 over 50. That's your second mark. And your third mark is simply for writing the formula. So y is equal to 1 over 50 x. Such a good question. Hence, find the value of y when x is 350. Sure, that's y is equal to 1 over 50 times 350. It should be 7. 4 marks in like 30 seconds. It's really good. Again, this is actually a question that is deceptively tricky, even though it's only 2 marks. We have the vertices of a cuboid, and it's an x, y, z axis. which is something that really isn't shown that often in GCSE maths. This is very interesting. But essentially we need to work out the coordinates, or write down the coordinates of point A and point B. So how do x, y, z coordinates work? Well, again, the order doesn't really change. It's still x, y, but then the z goes on the end. So if you look at point A, you can probably see it's along the y and z axis, which means its x value is 0. It's 3 up on the y-axis, and it's 2 along on the z-axis. So, very interesting. For the points B, that is 5 along the x-axis, as you can see. It's 3 on the top, as in going up y, and then z, well, it's not at all along the z-axis, so it's just 0. Very interesting question because, you know, these three-dimensional axes is kind of rare to come up. Another standard form question. 8.35 times 10, and once again just count the digits. So 1, 2, 3, 4, 5, 6, 7. Job done. Just do the multiplication. Or I was thinking maybe I could do it in my head, but I'm not that brave. I could do 5, you know what? No, screw it. Why am I making things more difficult? To the power of minus 7 times 2.8 times 10 to the power of negative 9. That gives me the answer in standard form already. Well, that's nice, isn't it? Sure thing. Times 10 to the minus 15. Whoop-de-doo. Well, that was tricky, wasn't it? Okay, something slightly different at least. So Sheila invests £2,000 in a savings account for 3 years. The account pays compound interest at an annual rate of 2.5% for the first year and then X for the second and third. There's a total amount of 2124.46 in the savings account at the end. So the compound interest formula is the original amount, which is £2,000. Then you times by the percentages to the power of however long they're in there for. So for this one, it'd be 102.5%, which you can say is 1.025 if you want. That's just for 1 year. But then we're going to times it by x squared because there's 2 years, right? So it's x% for 2 years, which equals 2124.46. There is a common mistake I actually see because it's saying work out the rate of interest. And the reason why that's different is because that's not what x equals. X would equal something that looks like this. It's going to equal, so for example, in this case, it's 102.5%. That's not the interest rate. I wish to God it was, because that would basically double your money every year. But instead, the interest rate is just 2.5%. So at the end, you actually need to subtract 100. Now, how would you know to do this? Well, it is kind of tricky, but you should also try and apply common sense. If you get a number that's like 101.5, it's a good bet that the interest rate is not 101.5%. Instead, if you notice, you think, okay, that kind of looks like this, so maybe I need to subtract 100 from it. And I get that using logic is kind of scary in a maths exam, but you do kind of have to do it, sadly. So x squared is just going to equal 2124.46 over 2000 times 1.025. So that's x squared equals, then let's just use our calculator. So 2124.46 over 2123 times 1.025 gives me quite a long number. Square rooting it gives me a slightly, was it 1.018? It's going to be embarrassing when I get this. Whoopsies. I mean, I wasn't wrong. 1.018 if I round that. So again, that is actually the percentage in this case. So again, depending on how you set up your equation, you might have got 101.8%, but in this case, it is just 1.018. So hopefully you can see that that's what I've got so far. So again, we haven't got that 102.5 thing that I mentioned before. It's possible. This is the multiplier though. So here, we times by 1.025. So to get this into a percentage, here's what I'm going to, an interest rate. I'm going to times by 100, which gives me 101.8%, which means my interest rate is 1.8%. So again, depending on what your value comes out to, depending on how you set up your equation, you might get a weird answer. So in this case, I saw this. I was like, it looks like the percentage multiplier. So I times it by 100, subtracted 100 from it to get the 1.8%. Some people, when they set up their equation, would get 101.8, in which case you'd need to subtract 100 and get to this, or you may need to divide. So just always think about how your interest rate looks, or how your answer looks, and compare it to what you know it should look like. This is again reverse percentages, so that has gone up to 112.5%. So I'm just going to do 225, just wondering how to set that up, divided by 1.125 should give me my answer. 225, 1.12, whoops. £200 for a train ticket, Jesus. All right. £800 a month, jeez. So again, 3 marks, inverse proportional, same circumstance. So the first mark is for setting up your equation. In this case, because it's inverse, it'd be k over c, because again, inverse means you have that. That's your 1 mark. Second step is for subbing in and working out what k is. So you have 25 equals k over 280, which means k is equal to 25 times 280, which I'm not going to do that in my head because I'm lazy. 25 times 280, 7,000. That's your second mark. Final mark is for having the equation and then subbing in to find out whatever the value is. Yep. So we're subbing in c equals 350, so we get, I can do this in my head, but I'm just not going to because I don't want to be embarrassed when I get it wrong. 20, yeah. Which is what I was going to get, of course. Just 20. Really, really nice set of questions when you get proportion like this. Another algebraic proof, lovely. Again, you want to expand, simplify, and then show that we can factorize out a 2 in this case. So when I expand this, we get 4n squared plus 4n plus 1. And then we have subtract 2n plus 1. So again, I'm going to use my magical powers. So the 4n squared is still the same. 4n take away 2n would just give me 2n. And 1 take away 1 is just 0. And because I can factorize out a2 from this, I can also factorize out an n. I get that, I know. It must be even for 3 marks. You get a mark for expanding, simplifying, and then your conclusion, which is where you factorize and say, therefore it's even. So this is another kind of somewhat interesting question. So in triangle RPQ, they give us a few dimensions, but they don't really show us anything. And it says, assuming that PQR is an acute angle. Okay, so if PQR is an acute angle, so here's how I'm going to draw this. I'm going to draw, thank God for autocorrect. So if I just label this as P, Q, and R, then PRQ is going to be this side here, sorry, this angle here. So I'm going to tick that off now I've done it. R to P is 8.7, and PQ is 5.2. And it says, assuming that RPQ, so this angle here, is acute. And the reason why this does make a difference is because if it wasn't acute, then it means that this is going to be obtuse. So for example, if this is acute, this has to be an obtuse angle. If this was acute, then this would have to be an obtuse angle. So it would affect how we work things out. And we need to work out this side over here. So probably the quickest way to do that is the cosine rule. Yeah, the cosine rule. So how does the cosine rule work? Well, you get given it in the exam. You do not need to memorize it. I'm cursed with this knowledge because I've done it so many bloody times. And the only labeling that matters is that the lowercase a and the capital A have to be opposite each other. So the angle and the side. So this has to be my A, this has to be my capital A. Other than that, B and C doesn't matter. So if we call this B and this C, we can now work out what we need to work out. So 5.2 squared equals B, which is 8.7 squared, plus C, which is, I'm just going to call it QR squared. Actually, should we just give it a letter? Let's give it the letter C. That's easier, because I've just realised what we're going to have to do later on. Minus 2 8.7 c cos 32. Good lord. Yeah, this is where things get fun. So the cosine rule, especially a few years back, you had to use the quadratic formula a lot because you had to solve quadratics. And if you notice, we have a c squared and a c. We're going to be using, how exciting, we're going to be using the quadratic formula alongside the cosine rule. Oh, I love it. The problem is, of course, is that how precise we can be. So for example, if I look at the value in front of c, it's 2 times 8.7 times cos 32. I'm willing to bet that that is a disgustingly long decimal. So it does actually help to leave it in terms of like cosine. So let's have a look. I'm going to write the c squared first. Then I'm going to simplify this. So 2 times 8.7, I'm using is 17.4, right? Yeah, 17.4. Minus 17.4 cos 32 c. And then I'm going to do 8.7 squared minus 5.2 squared because I'm moving the 5.2 squared over to the other side. So let's have a look-see at that. 8.7 squared minus 5.2 squared gives me 48.65. Wonderful. Plus 48.65 equals 0. Now as you can see, this right here is a quadratic quadratic equation, which means I can use the quadratic formula to work out what that side is. Now, on your calculator, there is a way to solve quadratics. So go to this equation slash function, polynomial. It exists even on just the normal kind of black and bluey ones as well. You may need to look up how to do it, but generally speaking, if you go to menu, there should be an equation button. So I showed a few students at the school I teach at how to do it. If so, then maybe I'll put a link in the comments or something about how to do it. But under menu, there should be an option to solve equations or solve quadratics, something along those lines. But we can just enter this into here, and it would give us the solutions. If not, you will have to use the quadratic formula, where b, so a is equal to 1, b is equal to minus 17.4 cos 32, and c is equal to 48.65. Whichever way you do it, you're going to get two answers for c. And this is where the whole acute angle thing changes things. So let's have a look. I'm going to first solve this. So we have 1 in front of here, then we have minus 17 point... I've actually never done this with cos, so I'm curious to see if this works. It does indeed. And that would be 48.65. 9.78, let's call it. Or 4.97. Now the question is, which one is it? And this is where the acute versus obtuse angle affects things. So, here's why. Imagine this. If this angle is acute, like it is here, the length of the line will be like this. However, if I make this angle obtuse, does it make sense that the side C would get longer? Imagine if I start increasing the size of the angle here. Well, if I increase it a bit, can you see how the line gets longer, right? And if I keep increasing it more and more and more and more and more, the length of the line will get longer and longer and longer to compensate. The line will get longer to compensate. So, in other words, because this angle is acute, we take the smaller answer. So in part B, where it inevitably says, if you didn't know it's acute, what effect would it have? Simple. We would maybe use the other side. And if we use the other side, then of course that changes what the area is going to be. So the area now, half AB sine C is a half. A is, let's say, 8.7. C is the 4.97. Sine 32. But that is the effect that the acute versus obtuse angle will have. An obtuse angle would make the side C the longer side. So it would be 9.78 instead. Whereas the acute angle, it makes the side length smaller. And again, you can think of this as, if I increase this angle, then that means Q and R get further apart, which means C gets bigger. Very funky question, shall we say. But, you know, that's what we're here for. We've finally got a difficult question in the Naming for Grade 9 paper. Again, I promise you the other ones are a lot better. The other ones are a lot better, but this made it a little bit worth it. 11.5 centimeters squared. So for part B, what effect would it have? Well, we may use C equals 9.78. Why? Because we don't know which one it would be if we didn't know it was acute. Therefore, the area would increase. And why does it increase? Simple. It increases because we would be timesing by 9.78. In fact, I'll show you, right? We're increasing the number that we're timesing by. So, of course, the overall area should get bigger. Of course it would, right? Because the number's bigger, so of course the area is bigger. That would be the effect. It looks almost double too. But the area would increase. That's what they're looking for. Venn diagrams. Cool. S is square numbers, E are even numbers, and we have this over here. So I like to go through, when they've written down all the numbers, I like that. What I'm going to do is I'm going to go from left to right, and I cross off the ones I've done. There's a reason for this. It's because any leftover numbers have to go outside, in the box, but outside the circles. So 1, is that a even or a square number? It is a square number. 2, is it even? Yes. Is it square? No. 3, is it square? No. Is it even? No, so it goes outside. Again, the most common thing I see is students forgetting to put stuff outside. Now, it's 3 marks. The way it works is it's actually called positive marking. You start with 3 marks, but every number that you put in the wrong place or is missing, you drop a mark. So basically you have 3 mistakes you can make. Well, 2 before you get no marks. 4, is it even? Yeah. Is it square? Yeah. In the middle. 5, is it square? No. Is it even? No. So it goes outside. 6, is it square? No. Is it even? Yeah. 7, is it square? No. Is it even? No. So it goes outside. I love saying this over and over again. For 8, it's going to be even. 9 is square, but it's not even. 10 is even, but it's not square. 11 is neither. 12 is even, but it's not square. There we go, 3 marks. Fantastic. Now this, set notation, it is in your spec, but again, not always shown, but this is the way I like to read this is S intersect E, or S union, no, it is intersect E. I like to think this looks like an N. So it's like you're saying, what's the probability of S and E? S and E, S and E. So it's a probability that something is in S and E. S and E. So this one here means and. So we're looking at the intersection. Well, how many numbers are in the intersection? There's 1. Out of how many numbers in total? 12. So it's a 1 in 12 chance. Lovely. So with this one, write as a product of prime factors, so good old-fashioned factor tree. I personally, if it's even, I just like to divide by 2 because it's just the lazy man way of doing. It's a lazy man way of doing it, and then of course you just have the calculator anyway. So if you don't know what it is, you can just look it up. Life's nice and easy. When you get to this, you're gonna have to divide by 9 and 7. So 7 and 9. I'm well aware I haven't circled this, and then 3 and 3. That's meant to be a 2. Jesus. And so that's going to be 2 times 2 times 3 times 3 times 7. Or if you want, you can put it in index notation, which is what I'm going to do. Now, some students have asked me, do you have to give it in terms of indices? The answer is no. You only have to if they say leave written in index notation, or they'll tell you to. The reason why I like to do this is because you never lose marks for this. So it's just easy to kind of work it out. But work out the value of the highest common factor. Highest common factor, all you do is you look at what's in common. So here we have 2 to the power of 5 and 2 to the power of 2. So 2 to the power of 2 is in common. Here we have 3. Here we have 3 squared. So 3 is in common. Here we have 7. Here we have 7. So 7 is in common. So 4 times 3 is 12. 12 times 7 is 84. Yeah, I think so. Good. Perfect. Completing the square, a grade 9 topic. But again, I do quite like completing the square. It's not too bad in my opinion. How does it work? Well, it works like this. If you have an expression like this, so you have x squared plus bx plus c, then you're completing the square as x plus b over 2 squared minus b b over 2 squared plus c. So if we sub that in, we get x plus, b is 10 in this case, so we get x plus 5 squared minus 5 squared plus 29. So we get x plus 5 squared. That would be minus 25 plus 29, so it's plus 4. Job done. 3 marks, really, really good. And then it says write down the coordinates of the turning point. I can explain why, but essentially all you do is you swap the sign of what's in here, so that becomes minus 5, and you keep the sign of what's outside, so plus 4. What's really good about this is even if there was like a 3 or a negative 3 or a 13 or whatever, the turning point doesn't change. All you do is you change the sign of what's in here and you write what's on the outside. That's your coordinate. Never, ever, ever changes. Really, really useful. And that brings us to the end of the paper. So again, if you have any topics you want me to go through before paper 2 and paper 3, do let me know in the comments, or just like the comment or whatever one you want to do. I would recommend you look at the other grade 9 papers because they are, in my opinion, more tricky than this, and they have better questions than this. So especially the set 2 and the set 1 are really, really good. So I would recommend just going to the description, opening them now and just flicking through them. They have some really, really good questions in there, and they're designed more like a test paper. Obviously, you won't have an exam that has 27 questions. It is literally like a 20 to 23 question paper. They're really useful to go through. But again, if there's anything you want me to go through, then let me know in the comments. But best of luck with your revision. I'll see you in the next one.